Okay, good morning or evening, and welcome to
MonsterMath67.
MonsterMath67. So you've been learning a little bit about quadratics. So I'm gonna give you some quadratics, and I want you to just kind of sketch them. You don't have to be plot points or anything. Just tell me what y equals x squared looks like.
Looks sort of like this.
Okay. What is that shape called?
It's a parabola. It goes on for infinity.
Okay.
Centered here.
All right. And so what if I change it to y equals x squared minus 2?
That would say that so x is 0, y is minus 2. When x is 1 or negative 1, they'd be the same thing. It's 0.
What?
Oh no, y is negative 1. When x is... So I think I get like the general shape.
Okay. So what happens?
We sort of moved it down.
Okay. By how much?
By 2.
Okay.
Move it down by 2.
Interesting. So let's do something like this. Y equals x squared plus 3.
Right, that should move it up by 3.
Okay. And why? Why does adding a constant shift it up or down?
Because all y values are, you add 3 to them.
Okay. Nice. All right. So now maybe a more interesting change. About something like this. Y equals x minus 3 squared. What happens here?
Well, x is 0, y is 9. So, up here. When x is, so it's different for 1 and negative 1. So when x is 1, y is 4. When x is negative 1, y is 16. It's gonna go off. It's gonna be way up there.
Okay.
So next is 2y is 1. Next is 3y is 0. So we have something that looks sort of like this.
Okay. So what's going on here? What happened here?
Here you moved it this way.
All right. By how much?
By 3. Or, yeah. So it seems to work in the reverse. You subtract 3, you move it over here, add 3, you move it this way.
Okay. Why? Why do you think that's true? Why do you think that happens?
The x value, you subtract 3 from the x value, I guess, this time. But that shifts it over in the opposite direction.
Okay. Now, without plotting points, I want you to take a look at one more parabola. Y equals x squared minus 3x plus 2. Okay. How would we figure out how to plot this?
Well,
or sketch the graph of it?
Well, we know the plus 2 will shift everything up 2. Like the...
Well, that's true, but you don't. I'm not sure you know what x squared minus 3x looks like.
Yeah, we don't.
Yeah. So we gotta find a strategy that's gonna help us.
You could make it something. You could make this whole thing a square.
Oh, okay. How would you do that?
So you could add 5 to both, or yeah. You could add 1 point, no. So this has to be 1.5 squared. There's the 3. It's a sum.
Okay. So what strategy are you following now?
I'm completing the square.
Okay. See if you can find a different strategy. Perhaps an easier strategy.
Well, factoring might lead us to something here.
Okay.
Factoring says it would be x minus 2 times x minus 1.
Alright, what's that going to tell us? X minus 2 times x minus 1.
Well, I know each one, well, this is sort of hard, them together.
Yeah.
Because, I mean, you're going to be moving it over this way, some distance.
Okay. But there's something really easy that you know about x minus 2 times x minus 1.
Well, I know that x equals 2 or 1. So,
What happens when x equals 2 or x equals 1? What do you mean?
this y equals 0 when
Okay.
x equals 2 or 1.
Alright, so here, let's say here's 1 and here's 2. Okay. And how can you sketch what the whole parabola looks like just by knowing those two roots?
The lowest point has to be in the middle,
Okay.
something like that. And you sort of follow it up like that.
Okay. So factoring is really helpful. Completing the square is also very helpful. It just, with an odd number in the middle, sometimes the math might get a little tricky.
Yeah.
But factoring actually helps. We find where the zeros are, and
We can use that to sketch out the parabola.
yeah, we can use that. So anyway, so it's just a little bit of an introduction to some squares. Good work today.